In this video, I will talk about 6.4, but let's first review 6.2. How do we add or subtract two rational expressions? The first problem, okay, so these two rational expressions, as you can see, do not have the common denominator. So the first step, we have to find the LCM to get the common denominator, but to do that we need to factor the denominator. So this one, we have to factor that. Use the formula, should be x plus y times x minus y. So the LCM is x plus y times x minus y. So to get the LCM, we need to multiply the second term by x minus y times x minus y. Okay, and now they have the same denominator. So we can add across. Okay, so let's just add across. Well, the x minus y times x minus y, for this one, let me use FOIL so we can simplify. And let's combine like terms. So we have x squared, 7xy minus xy minus xy with 5xy, and then plus y squared is my numerator. And then I have no way to factor my numerator, so this is my final answer. Okay, second problem. This problem, it looks easier than the first one, and it is actually. If you compare the two denominators, as you can see, one is b minus d, one is d minus b, almost the same except the different order. And then we explained in class, we can flip this, we can flip the second one so that it is the same order as the first one, but we have to change the sign. So it was plus, now it becomes minus. And then, because they have the same denominator, we can just subtract across. Let's factor the numerator, so it should be b plus d times b minus d. And then we can cancel. So the final answer is b plus d. Yeah, so it's actually shorter than the first one. Okay, let's look at the third one. Also subtract two rational expressions. This one takes a little bit more time because as you can see, the denominators are both quadratic, so we need to factor them first. Let's factor this. So that'd be x plus 5 times x plus 7. Okay, and this will be x plus 3 times x plus 5. I can just I don't want to rewrite this two expression one more time, so I just simply change the denominator to its factors. Well, now you can find the LCM. The LCM. So we have x plus 5, that's one factor. We have x plus 7, another factor, and then we have x plus 3. So there are three factors. Well, to get the common denominator, we need to multiply For the first one, we multiply x plus 3 over x plus 3 because we have x plus 5, x plus 7, but you see we don't have x plus 3, right? That's missing, so that's what we need to do here. And then same thing for the second one. We have x plus 3, we have x plus 5, but we don't have x plus 7, so let's times x plus 7 to both top and bottom. You see you have x plus 3, x plus 5, you have x plus 5, x plus 3, so there's no x plus 7. Yep, okay. And then let's multiply, so it'd be x times x plus 3. Oops, you still use the red color. And my denominator should be 3 terms. Okay, and then we can subtract across because now they have the same denominator. It doesn't matter what order do we use, right? And then let me simplify. Distribute and then subtract across. So 5x. Now remember, it's minus 5 times 7, so it should be minus 35. So that's x squared minus 2x minus 35, and then we have x plus 5, x plus 7, x plus 3 on the bottom. And then we can factor the numerator, so it should be x minus 7, x plus 5, and oops, sorry. Okay, and then we can cancel, hopefully, some common factor. Yep, there's a common factor. So the final answer, x minus 7 on top, and then x plus 7 times x plus 3 on the bottom, and that's our final answer. Okay, that's all. That's what we learned in 6.2. How do we add or subtract rational expressions? In general, you need to find the LCM, the least common multiplier, so that your expressions can be written in the form of common denominators. But if your denominators are not factored, you have to factor them first. So it will be easier for you to find the LCM. And then you just multiply the same thing to top and bottom to get to the common denominator, and then you subtract or add across and then simplify. Okay, now in 6.4, we'll learn how to solve equations. So instead of just add or subtract rational expression, we are looking where we want to solve an equation. Well, equation means there's equal sign in the expression, and you want to solve for a variable. For example, this one, t is the variable, so in the end, you need to get t equals something. You get t by itself, and then the number on the other side. That's what we mean by solving an equation. So don't get confused. Okay, well, whenever you have a rational term in your equation, you always multiply the LCM on both sides. So multiply LCM on both sides to clear fractions. So before you do anything, you always want to do this. If you clear all the fractions, your equation will look much easier, and it's much easier to solve. So like for this problem, the LCM, we have two denominators, 10 and 15. So the LCM of 10 and 15, which is 30, right? Because 10 is 2 times 5, and 15 is 3 times 5. So you have 3 times 2 times 5 would be 30. So we'll times 30 on both sides. So times 30 times 30, and times 30 to everything. Okay, so step 2, yeah, there's step 1, sorry. And then let's just cancel. So 1030 canceled, 1530 canceled. So we have 3t, okay, 3t plus 2t equals 30, which is 5t equals 30. And then, as you can see, we got t by itself if we divide by 5 from both sides. So t equals 6. And for this problem, we do not to check our solution. Next example, I'll show you another one. When the variable is on the denominator, we will have, there's one more step we have to do. Okay, let's look at another one. Okay, another one, it's I will do this. Okay, this one LCN, we have two denominators, 3t and no, actually 3t, 2. So you have to find the LCN of these 3 terms. So LCM of 3t, t, and 2. Well, 3 and 2 will be 6. T and t just, we just have t because we only count once, right? So we find LCM. And before you multiply the LCM both sides, let's check the restrictions in the domain. Well, because your denominator has variables, so we want to find out what numbers will make my function be undefined. So you will let the denominator be 0 and t 0. So the domain means t cannot be 0. So we have to check this. We have to find this because when we solve our equation, we want to make sure our solution will make function be meaningful. If our solution is not in the domain, we have to exclude that number. So we have to drop that solution. So that's a little bit different. And then let's time 60 to everything. So 60 here, 60 here, times 60 here, and then we cancel. So t and t canceled, 6 and 3 be 2, t and t canceled, 2 and 6 be 3, so I have 2 times 1 plus 1 times 6, t is gone, right, equals 1 times 3, t, so it'll be 2 plus a equals 3t, no, 2 plus 6, I mean the sum is 8. So a equals 3t, and then t equals a third. Okay, well, this is in the domain, so it'll be okay.